to Best Lives, the podcast that brings you the latest in pediatric research from BC Children's Hospital Research Institute. We highlight BCCHR investigators, clinicians, and trainees whose work is helping kids live their healthiest, happiest lives. Podcast guests share how their discoveries are changing the world of pediatrics and impacting families in British Columbia, the Yukon, and beyond. Whether you're a parent, healthcare professional, or just someone interested in the science behind kids' health, this podcast is for you. Tune in to stay informed and be inspired. My name is Kristen Hovitt, and I'm the Interim Research Communications Manager for BC Children's Hospital Research Institute. Joining me today is Dr. Alexander Weber, an assistant professor in the Department of Pediatrics, an associate member in the Departments of Neuroscience and the School of Biomedical Engineering at UBC, and an investigator here at BCCHR.
My name is Alexander Weber. I am an MRI biomedical engineer by training. My work focuses on developing advanced quantitative MRI techniques in order to help us better understand brain health and neurodevelopmental trajectories in newborns, especially those born preterm. For those who might not know the difference, most MRI scans that people get will be qualitative in nature. That means that the MRI scan will show us an image, and we can see if something looks normal or identify an injury or a tumor, let's say. Quantitative MRI scans, however, are like a measurement tool, which assigns numbers to physical properties. For example, how much blood flow is happening in a specific region of the brain. These numbers can be compared between people, across time, and between hospitals because they're more objective. So instead of just being able to identify things, we can also make direct comparisons between subjects.
And for the study we're talking about today, what inspired this study? Was there a particular clinical challenge, for example, that you were trying to solve?
During my postdoctoral training, I was trained in acquiring and analyzing an MRI scan that is sensitive to magnetic susceptibility. Basically, all tissues in our body, when placed in a magnet, such as an MRI, will either enhance or reduce the magnetic field. There's a common qualitative scan that is used clinically called susceptibility-weighted imaging that is used to identify brain bleeds, vascular abnormalities, calcifications, and more. That is because things like deoxygenated blood and iron will show up very bright on a susceptibility-weighted image. You can think of it as a metal detector. What I was learning about was how to take the same scan but analyze it in a way that quantifies that susceptibility value. Working with visiting clinician from China who had scans in newborn babies with brain injuries, we were interested in whether we could use this quantitative susceptibility technique to quantify oxygenation in the brain. We learned a lot from that study in our time together, but it was kind of limited. And when I became an assistant professor at UBC about 6 years ago, I was curious if we could improve what we had done to give a full picture of brain oxygen metabolism in the newborn brain. Working with Ruth Grunow, we devised a study to recruit and scan preterm infants at BC Children's MRI Research Facility and see if we could understand how the number of days these infants were on various forms of breathing assistance or ventilation support, while in the NICU affected their brain or their oxygen metabolism later on. You see, preterm babies have lungs that are still developing. In the womb, these babies get their oxygen from their mother without needing to use their lungs. But being born too early, they will often require ventilation to help them breathe, as they can't reliably get enough oxygen or remove enough carbon dioxide on their own.
So many people might not realize how important oxygen is for the developing brain, especially in very preterm infants. Why is brain oxygen consumption such a critical thing to measure in this population?
Our brains are energy hungry, and oxygen is a critical element for energy production. This is especially true in a newborn baby's brain, as their brain is still growing and wiring itself at an incredible speed. This is a critical period in a person's life, and we want to make sure that these babies are getting everything they need for their brains to grow and develop in order to set them up for a healthy life ahead. Many of the problems that we see in newborns, from heart, lung, or brain bleeds, lead to reduced oxygen delivery or metabolism in the brain. When our brains can't get the right amount of oxygen and use it properly, then it starts to malfunction. This can lead to problems at birth, but also for the rest of their lives.
You looked at how different kinds of respiratory support, from invasive ventilation to non-invasive support, affect brain oxygen consumption in very preterm babies. What did you learn from this? And was there anything that surprised you?
Our main findings, without getting too technical, was that the amount of days a baby was on non-invasive ventilation was positively correlated with the amount of oxygen metabolism we were able to measure after the baby was healthy and discharged from the NICU. We also found that the number of days these infants weren't on any kind of support was negatively correlated with their oxygen metabolism. A simple or naive interpretation of these results would suggest that these babies born very preterm should spend more time on non-invasive forms of ventilation. However, I need to stress that unfortunately, our study can't make that conclusion. For one, our study was observational, meaning we didn't randomly assign babies to the different kinds of ventilation support. So for instance, maybe the babies that had a lot of non-invasive ventilation were already healthier than those who received more invasive support. Also, we didn't have scans from healthy term-born babies to compare to, as understandably, guardians of newborn babies are not as keen to sign their babies up to research studies involving MRIs. If we did have data from healthy controls, we would have been able to compare if the oxygen consumption values we measured in our preterm cohort were higher or lower or the same as healthy newborn babies, as too much oxygen consumption can also be a bad thing. The thing that surprised us was that babies on invasive ventilation did not show a correlation with oxygen consumption. We initially hypothesized that these infants would have reduced oxygen consumption because they required the most help or they were the most sick. It's hard to draw any conclusions from this finding, however, as we did not have a lot of babies who were on invasive ventilation for very long.
One finding that really stood out was that babies in room air, or the air in the environment around them, didn't necessarily have better brain oxygenation. Could you explain what might be happening there?
As I said, it's hard to know if this was better brain oxygenation, as we did not have healthy controls to compare to. However, let's assume for a moment both possibilities. If indeed more time on room air or without any kind of respiratory support leads to reduced brain oxygenation later, that would tell us that perhaps we are being too cautious with the amount of support we give. In this scenario, it would mean that these babies should be receiving more support during their time in the NICU. However, without a control group to tell us the optimal amount of oxygen consumption, it could be that we are delivering too much oxygen with our supports and that more time on room air would be better. So we need more research to answer that question.
So your study uses an innovative MRI approach to measure oxygen consumption in different parts of the brain. What makes this approach different from others, and why is this important in very preterm babies?
There are different ways to measure brain oxygen in babies, and they all come with pros and cons. The conventional method used today is something called near-infrared spectroscopy, which is very safe, cheap, portable, and can give us the same kind of information we are looking for with our MRI scans. However, it only really gives us a single value for the whole brain and may not be the most accurate. Another method called positron emission tomography, or PET for short, would be the most accurate and gives regional values throughout the brain. Unfortunately, that method involves the injection of radioactive chemicals, which just isn't safe for the clinical purposes. This is why a lot of people are interested in using MRIs to study brain oxygenation, as it is perfectly safe, gives regional values throughout the brain, and we believe could be as accurate as PET. Most MRI methods, however, measure oxygen saturation, or the percent of oxygen in the veins, in a single slice of a single vein. Our method was novel because we used a technique that could measure this value regionally throughout the whole brain. While we still ended up averaging this value, future work could help us identify where in the brain oxygen saturation is abnormal, allowing us to answer more specific physiological questions.
Could this kind of MRI approach become a tool in routine neonatal care, or is it a research technology at this point?
At this point, it is only a research technology. Part of the reason is because these preterm infants are under constant care, and removing them from the NICU in order to get an MRI scan is something we try to minimize. That is why something like near-infrared spectroscopy, which can be done for cheap at the bedside, is likely to remain the primary tool to track brain oxygenation. However, the MRI scans we acquired are available and often prescribed on clinical MRI scans for preterm infants, but just need to be tweaked a little and analyzed in a special way. So it is possible that this could be prescribed as part of routine care for these infants down the road.
And I just want to make sure I'm getting enough of the MRI approach that you use because I know that was really novel and that's your focus. So, is there anything I haven't asked you about that you really wanted to include?
One of the main things we were measuring is this thing called cerebral metabolic rate of oxygen. It takes into account not only the oxygen saturation going in, so through the arteries, the oxygen saturation coming out, so through the veins, the amount of blood flow that's occurring, and also the something called hematocrit value, which is the amount of oxygen that blood can take up. So it's like all these elements that come together that give you a full picture. Whereas if you had only one of those elements, you wouldn't actually be able to draw any conclusions.
Were you there when they were doing the MRIs?
I was present for all of them. It was the first study that, starting as an assistant professor, that was like all my own and I was responsible for. So typically, when a researcher kind of starts a study, they might be present for the first couple, and then from there, they kind of trust that the technicians will know enough to make the right decisions. But I was so nervous that I wanted to be there for all of them. So it was very cute because these infants were, the way that an MRI works, usually each of our sequences, where each sequence gives us different information, typically takes 5 to 10 minutes, usually 5. And we had like an hour window. And in each of those 5-minute sequences, we need the baby to stay completely still. But we can't really tell the baby, please don't move. What we do instead is babies are great in the sense that when you feed and swaddle them or tuck them in, they tend to fall asleep and are happy to go through an MRI scan, which is a little surprising because MRIs are quite loud, but we also have proper ear protection for them. But invariably, these babies would sometimes wake up and we would have a nurse go in and kind of tuck them back in or make sure that they're okay. And so I think the sequences we had only would have really taken 25 minutes, but we usually took up the full hour because we would look at each scan, and if it looked like the baby had moved or the quality wasn't great, we would try to rerun it. So it was at times stressful because we could be approaching our like 1 hour window and haven't gotten the perfect image yet. And we're like, hopefully this baby just will stay still for this last scan.
That's so cute. Your study feels like a really hopeful one. It suggests we might have new approaches to protecting and supporting brain development in very preterm babies. What excites you most about where this research could go next?
I would be most excited about getting this technology to a point where doctors, as part of routine workup for preterm infants, are acquiring quantitative data on brain oxygen consumption in a way where they could use it to monitor and track what they are doing in the NICU with how the baby is responding. Too much oxygenation? Maybe we need to reduce support. Not enough? Maybe we need more. Is invasive ventilation too invasive? Is one area of the brain not responding well? Why is that, and what can we do? So giving doctors the tools they need to answer these questions and make informed choices would be very exciting.
If you could wave a magic wand and implement one change in the NICU tomorrow based on what you've learned with your study, what would it be?
Many babies who are born preterm will go on to grow up with no problems whatsoever, and that our current ways of measuring brain injuries aren't enough to predict which babies will require interventional therapy or not. That's why I'm so interested in developing quantitative MRI techniques that help neuroscientists answer questions about how the brain develops and how different kinds of injuries or disruptions will result in different problems later in life. If we had better tools to tell us exactly what was happening in these babies' brains, we could help set them up for the best possible future.
How does your research help children live their best lives?
I recently learned that despite the fact that the overall number of births in Canada has been declining since 2017, the rate of preterm birth appears to be increasing annually, and in 2023 was the highest it has been in 50 years. So with greater advances in care and technology, we are seeing more of these preterm babies survive and grow old. I hope that my research helps in identifying problems earlier on with greater accuracy, allowing for earlier interventions that will prevent children from developing chronic health conditions later in life.
Thank you for listening to Best Lives. If you enjoyed this episode, please subscribe, rate, and share the podcast. Stay tuned for more inspiring stories from BC Children's Hospital Research Institute.